let's just do a start. So this is going to be a conversation of chapter number 11 for R for data science. Um, we had to do a quick pivot. We had to do a quick pivot from the person who is going to lead today's conversation. So if anybody's watching this or reviewing this later, I am going to rely on some of the old previous notes that were written, but it looks like because of the addition change to the book, some of these notes may not align with the chapter. So I'm going to switch back and forth between the chapter and the notes. And it's just DJ and I today. So DJ, I think you and we're just going to discuss some things and it's going to be less formal. And then we can just kind of talk about like what we see and any questions that you have, or I can highlight some things that I think were important. Go from there. Is that cool?
Yeah.
All right, cool. All right, let me share my screen here. I'm gonna actually sit down. So stand up. So I'm gonna put my desk down. Okay, share my screen. Let's go to desktop one. Share. Okay, you can see my screen, right?
Yeah.
All right, cool. Let's chat a little bit about 11 here. Again, like here's that note. Again, I had to pivot really quickly because we had a scheduling change at the last minute. So I'm going to be switching back and forth, but really some of the things that we should get out of this is we should be able to describe the contents of a plot with labels. Like we're going to talk about like using different elements to highlight certain aspects of our plot. Then we're also going to call out specific features of like our data with annotations. So using annotations to highlight some more information. Then we'll talk about scale functions. So how to use scale functions or at least introduce them and how that relates to our individual types of data that we have. Talking a little bit about like controlling which data displays in the plot. So there's different ways to control how and what data we have within our plot. There's different ways to do that. And then we're going to customize the non-data elements using plot themes. And this isn't talked about in the chapter, but this is a carryover, is how to save your plots. So there was just a reminder of that. But to kind of get started here, there is a suggestion about like tools that you can use to create good graphics. And so what it does is it provides different resources that you can use. This link is broken. I don't know where this goes, but like this one right here is kind of interesting. Oh, this one's what? I thought the functional art. Oh, this link is broken too. So I guess this one's broken. Let me try this one. Extensions. Okay, this one's not broken. I could have sworn this one wasn't broken when I checked it, but I guess it is. But a good kind of resource is this extensions. This extensions, which is basically all the ggplot2 extensions that are available. I think we've discussed this before, but if you have a plot or a different type of like styling that you want to use, there are extensions out there that are available to help you do that. Pretty much any plot that you can think of or any type of styling that you want to think of, there's more than likely some type of extension that you can rely on rather than like having to do it yourself. Like anytime that you can figure out a way to like, if somebody's already done it for you, then like don't reinvent the wheel, like just figure out how to use the wheel they created, I guess is the way I would say it. So the book kind of talks about using labels and annotations. And as I was going and reviewing some of the previous notes, they had some really interesting stuff in here, kind of showing some different ways to do this. For the previous person who put these notes together, they used this data set called biochemical oxygen demand. I have no idea what this data set is. I don't work in biochemistry, but really there's just two variables, time and demand. And basically what they were doing is they were showing different aspects of what the book was talking about. And so here's kind of the first like plot that it creates. I'm not going to spend too much time talking about like what's being here in the plot itself, but rather focusing on what the chapter talked about with using this labs function. Okay. So the
Yeah.
labs function helps us add labels, labs, labels. Some common labels that most every plot is going to have a title, a subtitle, a caption, and any labeling with the X and Y axis. And again, it depends on the plot that you have, but in general, you're probably going to have a title, a subtitle, a caption. It should be pretty intuitive what these stand for. You have the title of your plot, you have the subtitle of your plot, and then you have your caption, which you usually add like source and byline or any additional information that you want to add. Um, this is kind of interesting because they use this package called TV themes, which I'm assuming is a package that somebody created. And they have like a specific function for their own theme. And we're going to talk about themes a little bit later, but like you can set up your own like specific type of theming or branding and just have it as a function rather than like, you know, constantly like repeating the same kind of like formatting stuff. So that's kind of cool. Um, did you have any questions about like how
No,
labeling works? Yeah.
no, I don't have
The
any question.
cool. Excellent. There's some like discussion about like you have the actual like how to do it, but there's also some more conversation about like what makes a good title, what makes a good subtitle, what should be included in a caption. And we talk a little bit about that when we jump over to the book, but there's some like kind of like professional practice depending on what type of audience you're trying to reach with your plots that you want to consider. So, um, here's some other examples. Oh, so this example basically, and this was taken directly from the book, is like in your labeling, you can go further by adding actual like math equations in here. So if you have some, and again, I'm outside of my depth because I don't do this very often, but like if you had some equation that's used to calculate the values of your X and Y axis, you can do that. But what you have to do is inside of labs, you have to use this function called quote, and then you can actually write what the equation is inside of it. I don't do this very often. I mean, I think it's very rare that I would do this, but if you do need to do it, it is available. So you can write math equations in your labs. It's flexible enough to do that.
Yeah.
Um, what was this one? Oh, and then they're highlighting this other TV themes thing, just another like general theme thing. It wasn't
Yeah.
talked about in the book, but it just changes the theme of the plot. It makes it blue, changes its other stuff. So, precipitation. What did this person want to highlight in here? This is kind of a cool example that I saw using individual. Oh, I think I know what this person was trying to do. So not only can we add labels, but we can use geom text to highlight specific points.
Yeah.
And so what we can do is using our data set, which is cities, and we have no, looks like they have a data frame here that they put together per precipitation and cities. I think that's what they're doing here. And basically what they're doing is why precip. So they're arranging by precipitation. So they take the DF, arrange it by precipitation, and then they have X 1 through 70, which is going to be 1 through 70, which I'm guessing they're using as average precipitation. So my guess would be that they're trying to show trend of annual precipitation. I guess I'm not understanding what 1 through 70 is here. Unless they're just using this as some representation of time, which I don't think they are because these are individual cities.
Yeah.
It's a little confusing what this example is trying to show in regards to like what this
Uh,
actually is. It's average precipitation, I know that, but like the line chart is throwing me off because I don't
yeah,
think
I
the
got
X
it.
is. Go ahead, what do you think?
So can you go a little up?
Yeah, sure.
So basically in the cities thing, they are precipitating the by only names, where you see it arranging it, like from the average of Sioux Falls is 26 by sorting the like complete list with the names. So I think they are doing like arrange function for that, like sorting the list from ascending to descending, and they're plotting like x equal to 1 to like 70. That I was thinking that,
Oh,
yeah.
oh, so it's like a ranking, right? So like it's
Yeah,
like X 1 through 70. So like the X is is representing like the city with the most average
exactly.
precipitation. Oh, okay. So Mobile, Alabama would be high. Yeah, it's
Yeah,
kind of confusing to me because it's a line chart,
yeah,
which a line chart in how I understand a line chart basically is usually a trend over time. So
exactly. But they
it
want to
looks
they want to
go
give it
ahead.
like a range so that everything will be in
Hmm,
order. From if it's not, they didn't mention the range, it will be a trend for sure. It will be like a
yeah,
trend, but they mentioned range to make it like which city has the like highest and which city has the lowest, like to know the number.
yeah. It
Yeah,
certainly looks cool. It certainly looks cool. It's just when you first look at it, it's kind of confusing because when I usually think of line chart, you have some time representation on the X, but it looks cool. Um,
yeah,
but how that's achieved, so like what I think it's really trying to highlight here is using geom text, using the city, using precipitation,
it's,
and using some of these arguments to like put like the Mobile San Juan. You know what's really kind of cool? Let me
yeah,
see. Because I'm also what's really kind of neat about this is check overlap. Oh, that's kind of cool. So I guess what's also kind of neat about this is like it's mapping precipitation to the size of the text. So as a city gets more precipitation, the larger the text gets. So that's
overlap. Yeah,
different. That's different. That's kind of cool. Um,
yeah,
So I guess what it's also highlighting here is just like you can use some of the same aesthetics here for geom text and it will translate it into the actual physical plot, which is kind of cool.
yeah,
Um, you also have some other like arguments to manipulate how the text gets arranged or gets put into the plot. You have your horizontal adjustment, so you get to use a
yeah,
categorical, like, do you want to adjust it to the right, to the left? And I think there's an option for center, but I have to double check. You can nudge it by certain values. So if you want to like make sure that it's not overlapping the point, you can nudge it a little bit, move it to the left or right. And then there's like this check overlap, which I would assume that check overlap is like it does some like algorithm to say like if Bismarck was hovering over Cheyenne, it would add a little jitter to move Bismarck so it's not overlapping, which
yeah,
is kind of cool. This is an interesting plot that highlights some really interesting things that you can do with geom text in regards to annotations. The line chart is a little confusing to me, but it's still interesting to see all these different elements come together. Um, so the good old iris data set. Um, let's see what this is trying to highlight to us here. So iris is a base R data set. It is like different measurements of different species. I don't think it's species. I don't think that's the right way to classify
no,
it, but different types of flowers is the way
flowers.
I
Yeah,
understand it, right?
yeah.
So they have like
I
sepal
think it's
lengths.
species. Yeah,
Is it species? I don't know.
yeah.
I'm not a botanist, so
No, no,
I
no.
don't
It mentioned like a
know.
color equal to species.
Oh, well, maybe I need to
Yeah,
read a little bit different. Um, so maybe I need to read it a little bit closer. Yeah, so basically what this is showing is just I guess what it's showing is like the different it's using the groups to add these labels for like the different groups of where they sit within the plot. So you have the three different species, Setosa, Virginica, and Versicolor. And inside of here in Geom text, it's using like a pipeline to it's using the pipeline. So it's grouping by species, and then it's filtering out for the max the longest for the actual for the longest, so flowers with the longest length, and then it's ungrouping it, and then it's using that for the data, and then it's plotting the label as species, and then it's basically just using like changing the size of the text, it's aligning it right, and then it's like checking overlap. So I don't think there's too much different here other than like, hey, you can use a dplyr
Yeah.
pipe, using like a chain of commands to do that. And then here's some additional like things. And it basically comes out like this. So pretty cool. So this next example, like if you want to add like some explanation in here, like say you want to have the central point of the plot or what you want people to get out of it, you can add that as like an annotation in your plot. And how you do that is you basically do that here. You can, I don't think I've ever, so MPG summarize displacement equals max displacement, highway is max highway. Oh, so all this is doing is just creating a separate data set for us that we'll use in geom text. It's taking the max displacement, it's taking the max highway mileage, and then it's just adding this extra variable, which is the actual label that you want to add into it. And then what that does here is it just adds that in the aesthetic label, data label, and then it adds some additional like change it to gray 40, make it a different size. It's vertical adjustment top, so up here top, and then it's it's H adjustment to the right. So now you have like the main point of the plot being highlighted inside of the plot, which here in MPG, the miles per gallon data set, the bigger the engine, the less highway mileage you'll get out of it. So, what's the takeaway from this example that's used in the notes? I think it's basically just the concept that like you can label individual points, you can label groups of points, or you can just have like one piece of text representing something, right? I think that's like what these notes are trying to get at here. You have the ability to change where the positioning using HJust and VJust. Excuse me.
No,
Go ahead. Go ahead. You got a question?
no, I'm just seeing that. Yeah.
Yeah, so it's just kind of nice to see like, okay, if I do HJust left, VJust top, where does the label actually go? And these combinations will lead you to either being like top left, top, right, left, center, so on and so forth. There was an exercise in here that tests you on this. It's kind of the same thing, like using HJust and VJust to put it in the top left, the top right, bottom left. So it's just using those combinations to move the annotations throughout the plotting space. Okay, so let's see here. There was some other discussion about like using different types of geoms to highlight annotations, and I might actually jump over the book because I think the book does a better job of this. But you have things like geom H line, geom B line, geom rect to draw a rectangle around points, and geom segment to actually do an arrow. And so I'm gonna jump over to the book because I think the book does a better job of explaining these. I don't think I've missed anything that I wanted to. Um, I do want to highlight that this was kind of a nice example um of how to like use different labeling this way. So using mutate and case when to like change the naming of these, that was kind of cool. So basically it's just creating the label info in its own data set and then using case when to create human readable labels, which I thought that was kind of cool. I do that once in a while. Um, You can also change the styling in your
Yeah.
labels. So like if you wanted to like bold them, italicize them, you can. That was kind of neat. Oh, if you want to get rid of a legend, and I always forget this. This is like the one thing that I always Google. Like you think, but I probably like I have probably looked this up like have to be hundreds of times, if not thousands of times. Probably not thousands. That's kind of excessive, but hundreds of times I've
Yeah,
like, how do I get rid of a legend? Here's one way to do it. In your theme, just call legend.position equals none because you don't need it, right? In this case,
yeah,
because you're using labels, you don't need a legend. It's just redundant information. And so you can just do theme legend.position equals none and it gets rid of it. I guess the other thing that gets labeled here is geom label REPL. So this comes from the GG REPL package. Um, GG REPL, usually like if I have a small amount of data or if I'm doing like if I'm like plotting like small amount of points, I'll rely on geom text, which is part of ggplot2. But like if I have more than maybe like three or four, I'll lean on like geom text REPL or geom label REPL from GG REPL because it algorithmically like figures out overlap for you.
yeah,
So it's really nice. It's a really nice package to just like help you like adjust for overlap in annotations. So anytime like I have a plot that has like text labels above like three or four like labels, I'll probably lean on like geom text REPL or geo label REPL rather than like geom text. But I don't know. Have you used GG REPL yet? I don't know if I've
uh,
showed you that yet.
no, I didn't get an opportunity to use it much. Yeah,
Okay, cool. Well, maybe you'll have the opportunity to use it more, but like look it up. Like GG REPL is um it's a really awesome like package to it's a really awesome package to help with just like text annotations and labels. It's just it works really, really well. The only thing that I don't like about it is like because it algorithmically puts this, if you don't if you don't set your seed, and I have to double check myself on this, because it does that, every time you re-render the plot, the labels will move. So like because it's like makes a calculation on the back end to make sure there's no overlap, so they'll constantly
yeah.
move. So you have to
Oh,
do some setting to make sure that they don't move before that. But that's like my only thing. And then here's geom text REPL. Here's the example of geom text REPL rather than geom label REPL.
yeah,
Um, before I open it up here, here's another example of highlighting specific points. So rather than using like text labels or text to like highlight specific points, using colors and different shapes are ways to help emphasize like points. So like if you had outliers within your data, shapes and color are great at doing that. And in this case right here, it's using two geom points, highlighting potential outliers, one using this red circle and then using a larger open red circle to say like, hey,
yeah,
these are, outliers within our data. Um, so do you have any
that's
questions
cool.
about, yeah, this one's really cool. I like this one. I
Yeah,
don't do this a lot, but yeah, go ahead.
no, that's cool. That's what I was saying. Yeah,
Um, I think if there's anything, yeah, there's some discussion about geom rect. If you really want to get like, if you really want to get like super hyper specific, like if you want to point out like one thing or a group of things, you have the ability to create arrows. Like you could create an arrow using annotate, and then also like geom rect, which can draw a rectangle around things. So like if you want to draw like a rectangle, um, that's a really cool thing to do. Like if you have like, look at these specific clumps of points, like you can draw a rectangle around it and shade it, um, which is kind of cool. The other thing that I learned when I was reading this was this little trick right here with stir wrap. I thought this was really cool. Um, so I don't know if you've noticed this yet, but I'll highlight it here. So, oh, okay, here it is. Okay, so you see the text that gets outputted.
yeah,
So this is the function, or so this is like the what we're doing. We're taking this character string, and we're passing it to this function called stir wrap, and we're setting this argument called width. And what it's doing is it's basically like setting this character right here to like drop things down. is basically, so like this is a new line. This is a representation for a new
Yeah.
line. And so what's really cool about this is if you had like a text string that was like 90 characters long, it would add additional slash ends to them. So
Yeah.
it's really, really kind of nice. I find this nice because like my old workflow before I reread this
Yeah.
was, and I'm going to integrate this, was like, oh, I'm just going to kind of pick a point and put an N here and then put a point N here and then like re-render it and look at it,
Yeah.
do it again, re-render it. But like I could save myself so much time by just
Yeah.
doing this. Like, I
Yeah.
don't know. Learn from me now. Do this from now on.
Yeah.
You're
Yeah.
probably
I can
going
note down it. Like, yeah, I can note down this. This function helps a lot. Like, instead of running so many times.
to, yeah. Which, like I said,
Yeah.
I've been doing this a long time and you learn like these little tricks. So take it from me, use this now. And you probably start seeing this in my code that you look at. This is how you draw an arrow. Like if you want to highlight like a very specific part of your plot, like you could do it this way. Um, let's see. Okay, cool. I think that's that. Let's jump over here. I don't know if this does talk about scales. Um, before I jump over and talk about this, um, let's jump over back to the book because I think the book is a little bit more clear on
Yeah.
scales. So the first thing about scales is your scales. Well, first thing to know is like if you run this, these two sets of code are equivalent. Okay. So this code is the same as this code. Okay. Um, every ggplot is going to have a scale function that's run with it. And these scale functions are going to be associated with the type of data that you're plotting. Are you using a continuous type of data? Are you using a discrete? Are you using a date? So how you modify those are going to be based on the types of data that you have, whether it's continuous, discrete, whatever, whatever. So if you want to modify the scaling, and I guess I probably need to explain that a little bit more. If you want to modify how that scale is represented, whether you transform it in some way, and or if you want to like change how the ticks are represented. So like say rather than like 1, 2, 3, 4, you want to go by fives, 5,
Yeah.
10, 15, 20. You want to go by tens, 10, 20, 30, same on, you're going to use these scale X, whatever. If you want to change date representations, right? If you want to change, like rather than being like a weekly date, you want to change it to monthly, you would use scale X date, scale Y date, so on and so forth. Um, so that's basically what this was talking about here was like, regardless of the plot that you're making, it's always going to run, it's always going to have this run in the background. But if you want to modify it, then you have to use these and then change the arguments inside of it to change whatever you have.
Yeah.
So that's basically what it's doing here. So here on our y-axis, if we want to start our ticks at 15, go to 40, and in like units of 5, we would have to use this right here. We'd have to use this argument called breaks. Start at 15,
Oh,
go to 40, go by 5.
yeah.
Yep. All this does is this just creates a numeric vector. So like it would start at 15. So it'd be a numeric vector starting at 15, going to 40, increments of 5 in between. So 15, 20, da, da, da. So,
Yeah.
but then you use this for the breaks and then it just fills in the breaks automatically for you. So, and how this works, we have the y-axis and it's a continuous variable because it's numeric and it's 0 to infinity. And so basically we have that there, right?
Yeah.
So, I always forget this little trick about sequence. I need to remember this more. I don't use it as often. This one was kind of cool. The discrete ones. I did not know this. Um, so if you want to label your discrete variables, because in the data set, like the different types of drivetrain are like 4, F, and R. you can automatically set the labels here in your scale function, which is kind of cool. Like I didn't know this. So like rather than doing it like in like a mutate, you can just do it right here in the plot. So like
Yeah.
it's represented four in the data, you can do the text label four wheel, and then it gets represented in your actual legend as four wheel front and rear. I don't do this as often as I should. I should do this more than I do, but so but do you have any questions about this? About any of this
No.
like scale stuff?
No.
Um
No.
you can change the representation. So there's like label dollar, label percentage, label whatever. Like say you're trying to represent dollar amounts on some axis, you would go scale, whatever, continuous labels, label percent, or label underscore dollar. So that's what it's doing here, and it automatically represents this.
Yeah.
If you want to abbreviate things, so like 1,000, 1,000,000, I don't know if you're working at a scale of like 1 billion, you can use some of these label dollar functions
Um,
to like set the scale and do the suffix, which is kind of cool.
yeah.
And then here's that breaks thing again, 1,000 to
Yeah.
19,000 in increments of 6,000,
6,000. Yeah.
which is kind of a weird step, but
Yeah.
if you have a specific case for it, you sure can. And then here's label percent. So if you had it represented as percentage, you want label percent, right? You can do that. Oh, this one was kind of cool. Um, so this is highlighting breaks, presidential, date labels. Oh, so the first thing that this is doing is that's showing like if you have a date variable on the X, you can change the breaks here, but you can also use you can correct me if I'm wrong. I think this is Unix. I don't know, but are you familiar with like the Unix date representation syntax?
Like a year, month, date.
Yeah, so like you have like different like code here with like the percent to
Yeah.
represent like,
Oh,
year, month, day, abbreviated month, day, all that kind of
yeah.
stuff.
Yeah.
You can do that here. So inside of the data, this is more than likely an actual date like 2021-01-13.
Mhm.
If you use scale X date, you can change the representation using this kind of like unit. I think it's Unix syntax. I'd have to double check that, but
Yeah.
you can change it. Um, I think it's. Let me look at something here real quick because I think it's stir something. There's someone had it like someone showed me that there is some documentation that has all of those. Let me see if I can. Oh, yep, it's right here. So if you do, yeah, let me bring this back. If you do this question mark strp time and you scroll
Okay.
down to details, it will give you all the different representations. So you can do like abbreviated month name in the current locale of this platform. You just do %B, or if you want like the full month name, %B, or
Yeah.
if you want like the full date time representation, you can use %C. So if you want the documentation of how to do this, you can find it online too if you type it
Yeah.
in. But like if you're in R, just do question mark strp time
Yeah.
and you just dig down into it and it gives you all the different like timestamp elements. So just a little tip.
Yeah.
Um, Post date time, legend layout. You can change where the legend goes. You just have to basically inside of your theme do legend opposition like top, left, right. I'm gonna be honest, I've been doing this for a long time. More often than not, I just do the default, let it go to the right,
Yeah.
but there might be applications where you want to put it somewhere else. So, but I usually just
Yeah.
default to the right, which is probably me just being lazy. Um, trying to think. Oh, you can also change how these are represented. Like you can get very hyper specific. Like if you wanted to be 2 rows of data, you can do that with this function guide legend. You can also change the size of these. So if you want your legend to be bigger, I'm not going to
Yeah.
talk about it now, but if you're interested in looking at this, you can also change the symbol inside of here, like, and you can
Mhm.
actually do your own custom, like, you can put a smiley face in here if you knew how to do
Yeah.
it. So there's all kinds of stuff that you can do with this. You can totally hyper customize the legend. But this is just showing you some basic stuff like change it the columns and rows and change the size of it. So um,
Yeah.
replacing a scale. Um, I know I know you don't have like a statistics background, but there might be some other people. I know Tosan joined us, so hi Tosan. Good to see you. Um, sometimes like with like certain types of data, and again, I'm going back to my statistics 101 courses and my grad level statistics, so because I'm not a true statistician. Um, like sometimes how you view your data, like the scaling kind of changes your interpretation of it. And so what you can do is there's what are called transformations to get a better
Mhm.
view of the actual relationship of the data. So rather it being like its actual representation, you can transform it into like a log, or you can log
Yeah.
it, or you can do the inverse of it. And so sometimes when you do this transformation, it's not the true scale representation of it, but it allows you to see what the relationship is, or it allows you to more clearly see what the relationship within the data. Um, and ggplot allows that. And basically you can either transform it here in your aesthetic, but you can also do it automatically with the scale function. So if you wanted to log your X, you would just do scale X log 10 and it transforms, it automatically does the transformation for you.
Yeah.
Knowing the work that you and I do, we don't do this very often, but like in other
Mhm.
contexts, it is a tool that people use to better highlight the relation, the actual, or to highlight the relationship within the data. And again, if somebody's watching this later and I misrepresented that, let me know. But going back to my statistics courses, that's what I was taught. So ggplot has those things. You just have to do that with scales. Uh, yeah, sweet. So yeah, Tosan says the same thing. I just learned about the scaling myself, taught SAS class. Glad to learn how to do it in R. Yep, absolutely. So um you can do it here, but ggplot 2, you can do it with a scale function. So pretty cool. Um if you want to change the color, so if you have a color aesthetic within your plot, so here in our case here, we're using geom point and we're using the color aesthetic. We can use this function scale color brewer. And what this does is it has a preset of palettes that change the colors for you. I lean on this sometimes to use it. I don't know if yeah, it shows all the different ones. There's all kinds of presets that you can select to automatically do it, whether it's like continuous in nature, whether it's like discrete, or whether it's like divergent. You just have to select the palette that you would like to use. It is really important to remember that if you're trying to increase the accessibility of your plots, to be mindful that, some people have, um, like color blindness and so on and so forth. So like red, green color blindness, you want to be using a palette that um, improves accessibility of the plot information. And Scale Color Brewer, and I think the Veritas package has some scaling functions that give you access to preset palettes that are more accessible for some people. Um, this is really important, especially for like depending on your use case. So, like, I know if this is going to be like written in a journal, like an academic journal, or if it's going to be publicly accessible information, that's stuff that people need to consider. Um, so here's another example of scale color brewer. Here's the different palette sets. You can dig more into this. I think just for the sake of time, I'm not going to dig too much into it. But if you want to get very hyper specific, like if you want to manually set your colors, you're going to use scale color manual, and you'll actually give the specific values to it. So if you wanted, if you had like, you had some data. Oh, this is so presidential data focused on like the terms that presidents served in the United States. You have the Democratic Party and the Republican Party. If you wanted to use the colors to represent that official's term in office, you can do that, and you can specify that with scale color manual. Values equal what is the Republican value using the hex code, Democratic using the hex code. For people that aren't familiar with hex code, this is basically like computer language speak for like the very specific definition of a color, right? Goes a little bit more in depth than that, but it's just like a very specific representation of a color. So biggest thing is you can use pretty much any color that you want in ggplot. Like you can get very hyper customized. Let's talk a little bit about, let's see. Oh, here's the example of Viridis. I think it's Viridis or Viridi. I can't remember. Somebody needs to correct me on it. But if you want to use this specific palette, it has its own scale function, scale fill, Viridis C, scale fill, Viridis B. And I think if I remember right, these are optimized to be as accessible as possible to many people who have, you know, color blindness or anything like that. So let's talk about zooming, and then I'll open it up for any questions that you might have, DJ.
Yeah.
Let me go back here. So that's scales. Oh, okay. So we're still following along with the notes. If you want to zoom, so there's different ways to zoom, right? So like say you want to zoom in on a very specific set of data, right? You can either like filter it out yourself, right? That's like one way to do it. Or you can go to using your scale functions or chord Cartesian to help you zoom in. So basically here's our data set. Here's our original data. Say we want to zoom in on like cars that have a specific engine size of 5 or 6. You can do that by doing a filter, or you can do that by using scale X continuous. So in our case here, we're using scale X continuous and scale Y continuous to set the limits, to say only show the data within 5 and 6 and 10 and 25, right? So you can do it that way.
Yeah.
Or you can use chord Cartesian. I don't use chord Cartesian very often. I use limits more. You can choose what you want to do. I think the book recommends, generally more useful if you want to expand the limits. It recommends that if you're trying to expand the limits, so if you're trying to give a little bit more space to the data space itself, it suggests using scale Y continuous in the limits. But I think if you want to like zoom in, it suggests using chord Cartesian. I don't really use chord Cartesian very often, but the book suggests using it. Full data. I'm trying to think of what else this was trying to highlight. Oh, so the book also talks about that you can use different scaling to highlight very specific, like you can use this to like filter out very specific types of data. So like if you wanted to set your own scaling for individual parts of the data that you want to highlight, you can do that. But it also does say like, rather than doing it this way, you probably should just use a facet. Like you should just use a facet wrap, which would just be small multiples of this. You would just use the function facet underscore wrap or facet underscore grid. But if for some reason you needed to use the scaling functions to do this, to split the data into individual small multiple plots, you can. You have the flexibility to do it. You just have to do it this way. And that's all this is doing, is it's just setting a range off of this vector. So you have displacement. It's just setting the range, like what's the low value and the high value. Same thing here. And then in drivetrain, it's just doing the uniqueness of it. So any questions on zooming?
No.
Yeah, it's a very specific thing. Go ahead. Yeah, great. Go ahead. All right, cool. or Tosan, if you have any questions, let me know. Happy to answer them as
Yeah,
well. Go ahead.
I'm not sure if this is exactly on zooming, but I had an experience. I made a plot and I wanted to put that into a quarter report. And I observed that the subtitle of my plot, it did not fit in perfectly in my quarter report, so it was halved. And I'm not sure if there's a way to correct that with ggplot, or if it's something I have to work on with my quarter file.
Yeah, so that's a great question. So zooming is only going to affect the actual data space in here. So that's only going to affect the values within the actual plot itself. When you start talking about like the labels and stuff like that, there you might be able to change that with some of the Quarto options like fig height and fig width. But if it's an issue with like the length of the actual subtitle itself, what you might rely on is using this strategy here, which is let me see. Oh no, Docker snooze. I don't need Docker right now. Would be sorry, I'm scrolling y'all to death here. Annotations. See, I don't want to do that. Let's do sorry. It's something where it's like stir. Oh, here it is. So you would use something like this, like stir wrap. And what it's doing is it's adding this character like /n to create a new line. So when it actually adds it, it will have this, it will hit that /n and it will drop this down to a new line. So that might be another strategy to take care of that. I don't know. Did you try anything
Yeah.
else to see if you get that to work?
Okay. This could work. Thank you. Because I had an issue with the length of the text, so I think wrapping it would work. Thank you.
Yeah, so wrapping might work. I think there's some other things that you might be able to do ggplot2 wise that extends the white space around the plot itself, but I really don't do that very often. But there might be other options that you can explore to look that up. But post that in the Slack because there might be somebody that's more versed in that that could be helpful. But wrapping is a great strategy, for sure. Okay, let's talk about themes. What do I want to cover here? Let's see what's in the notes again. Again, sorry for jumping back and forth. Like I said, there was a quick pivot, and I didn't have time to go over these. So what do I want to cover about themes? So themes, you have you have multiple options with themes. You can use some very stock themes, and here are the different stock themes and what changes visually. So like you can dig into these. Like if you want theme dark, you can use theme dark. I usually go towards theme minimal. That's the one I usually go to because once I use theme minimal, I have very hyper specific type of theming that I follow. And how you change those very specific aspects is you use this theme function. Um, I don't think it's worth our time going through all of these, but you can kind of pick apart and see what some of these things do. So like if you want to change like the different how the text is represented in the plot title, you can do that. You would just have to do plot.title in your theme and then use this thing like element text, space, bold, change the size, comma size, so on and so forth. I do suggest there's a lot of different theme elements in here that you can change. I'm trying to think. Let me see. Theme are I'm just checking something here with ggplot2. I'm being mindful of the time too, because we only got about 7 minutes left. But um ggplot2, if you do is it args? Args. There's a way to see all of them. Yep, here you go. So if you do, I'll show you. Like usually if I'm trying to find like different specific elements that I can change, what I do is if you run this function args on this theme function from ggplot2, you can see all of the different elements that you have access to change in the theme. Okay. And it's a lot. You could probably put a specific number to it, but you can change pretty much anything within the plot, and you just have to find it. If you want to change the axis minor ticks length x bottom, you just have to do it right here. You could access that, write the function, use the function that you need to change those elements, and then change it. In all honesty, you just have to dig for it to figure out how to change those things. But and know that there's different like inputs to it. So like if you want your legend direction to be different, you can change it to be represented horizontally rather than vertically. You just have to change the theme element. Just for the sake of time, I'm not going to dig too much into it. The big takeaway here is you have these like overall stock themes that you can change, like change the whole theme of the plot. And then you can get very hyper customized with very individual theme elements. So, and it takes a little bit of time to learn how to use these, but you pick them up pretty quickly. And honestly, you get to a point where you have the same theme across all your plots, and you can just like write a function or just have the same theme over and over again, and you don't think about it. So, last thing before we get to layout, and this has always been a question for me, was like, why is the default always this gray theme? Because it's just like, it just doesn't make sense to me. But then as you like read it, it makes sense. Like the book kind of highlights the reason why the stock is a gray background is because it clearly highlights the data in the data space and the axis labels, or the axis, like not labels, but the actual axes in the plot. Because there are major axes and minor axes. And if you didn't have that gray background, it's really hard to like see them. And so that was a design decision from ggplot, was to just have the stock theme be gray. So that's why you get gray. It's not because someone was like, this looks good. It was like, nope, it has a functional purpose. And it's mainly so you can better see the elements before you actually go and change the themes. I will tell you that like the students that I have for a class that I teach, I always tell them like, I don't want to see the gray theme. Like, get rid of it. Like, it's good to see the data set, but like usually I point them to be like, use a different theme. So, but I'm sure someone can make an argument against that, but that's where I usually stand with it, is use a different theme other than the stock gray, because to me it's like it doesn't look good. So the last thing that I want to highlight, and I can't dig too much into this other than like highlighting like and pointing you to learning more about this, but like say you have multiple plots that you want to arrange into a single graphic, there is a package called Patchwork. Patchwork is really, really awesome. I like using Patchwork. I would suggest checking it out, but what Patchwork allows you to do is it allows you to create single graphics from multiple plots. And it has a really intuitive syntax on how to do that. So it just uses these operators to like put plots together. You can also make very complex plots where you can put things side to side and stack them. And it's just this really basic syntax. In addition to it, Patchwork is really, really nice because it has, and I'm just going to highlight this and point people to a place to look for it. It has these additional functions to help you like add different elements to the entire graphic. So if you want like an annotation that is representative of the entire graphic that you created, not a single plot, you can use plot annotation. If you want to manipulate the specific layout, you can use plot layout. And if you want to add like elements that get applied to everything in the plot, you can use the ampersand and then theme. And then this theme will be applied to the entire graphic, not just the plot itself. So I push people to go check out Patchwork. It is, oh, I clicked on the link. I highly suggest looking at this. I even wrote a blog post about it because it's really great. And the chapter only covers like the very, very like foundational stuff that Patchwork provides to you. So like I said, I didn't cover all the specifics of it, but it goes a lot deeper than this. So if you have a need to combine plots together, go check out Patchwork. It's really intuitive, really useful. It's very helpful. I think that's it. I think that's everything. The notes have this reminder of how to save your plots. GG save. Go check it out. That's how you save your plot. But I'm at about 45 seconds left. So I'm going to open it up for any questions that people might have before we end our conversation. So Tosan asks, if I want to create my custom theme, I just need to save my code as a function, right? So yes, that's one way to do it. That's how some people do it. That is one way. There is, let me look it up. There's also another way to do it for like your reports that I've seen some people do. Like if you have like let me see if I can find it. It's like set theme or theme set, I think is the other one that I've seen people use. So like, yeah, let me pop it over here. So like if you don't want to write a function for your themes, which I highly suggest, like if you have a common theme that you're going to use across everything, like create a function and just store it somewhere, especially if you're able to create a package. And I know this is for people that are just getting introduced to this, but yeah, write a function for your theme elements. The other thing that you can do is like if you just want to set your theme for like a specific report, there's this function in ggplot2 called theme set. And this is really useful because you can set theme elements up at the top of your report or your Corto document, and it will translate to every single plot within it. And so I've seen some people do this in the past. So Tosan, I'm just going to, because of the sake of time, I'm just going to push you to this to check it out as another option to set your theme elements outside of creating a function. But depends on the context, depends on your use case. But this is another option outside of creating a like a function for your themes. So cool. Any other questions? DJ, you good? You got any other questions or anything that I can help clarify?
No, I'm good.
Okay, cool.
Yeah.
All right, cool. Well, I'm glad everybody joined in today. Like I said, I appreciate you all having a little bit of grace with me because I had to pivot really quickly with the schedule. But hopefully y'all got something out of this, and I certainly learned a couple things from this chapter, and I hope everybody else did too. So
Yeah, you too. Thank you so much.
all right, cool. Talk to y'all later.